In today's video, you're going to learn about what a median and what an altitude of a triangle is. By the end of the video, you'll be able to draw medians and altitudes in diagrams, accurately labeling them in the diagram with tick marks, and then apply the properties of medians and altitudes to set up equations and find missing measures. So we're going to use this model. It's called a Frere model, and it's going to help us understand these vocab words a little bit better. So the first word we're going to look at is what is the median of a triangle. So the exact definition of a median is the line segment from a vertex to the midpoint of the opposite side. And there are a bunch of different important aspects of this definition. So if we just want to highlight a few, it's the line segment from a vertex is going to be very important. And then the fact that it's to the midpoint of the opposite side, okay? So I think what's helpful is if we look at an example, the picture, first to kind of decode this definition. So if I have triangle A, B, C, okay, in this first example, I want to draw the median from the vertex A, because we know it has to go from a vertex, so let's draw the median from vertex A. From the definition, we can see we have to go from vertex A, so we start at vertex A and go to the opposite side. Well, first we should figure out what is the opposite side of this vertex, okay? The opposite side is going to be the side directly across from the vertex, so that's going to be the side BC. But looking closer at our definition, we wanted to go specifically to the midpoint of the opposite side. Well, we know that the midpoint of a segment is the middle of the segment. So the midpoint of BC is probably around here somewhere. Okay, I'm going to call that point D. Okay, so finally, my median, if we're putting this all together, starts at the vertex A, right? And it goes to the midpoint of the opposite side. So it starts at A and it goes to D because D is the midpoint of BC, right? Now, we could take this one step further because we know that midpoints, right, split segments into two congruent parts, right? So if D is the midpoint, that means that BD is congruent to DC. Now that we know the definition and we've seen an example of a median, I want to come up with a few characteristics that will help us understand medians a little bit deeper. So first, we can kind of use our knowledge on the last unit in proofs and realize that the median, because of the definition, like we said, splits that opposite side into two congruent segments. In this case, the median AD split this into two segments. BD was congruent to DC. Secondly, I think another very important characteristic is how many medians are in each triangle. So if the median is a segment from a vertex to the midpoint of the opposite side and a triangle has 3 vertices, that means that every triangle has exactly 3 medians. Lastly, I think it's really important to look at some non-examples and some common mistakes that students make when they're trying to draw medians. So first, right, if we have this triangle here, let's call this like X, Y, Z, okay? A common mistake is to assume that this red line here is the median and it splits segments like this, okay? This is a common mistake because notice this is not from a vertex, okay? And we know from the definition that our median has to start from a vertex, okay? We've actually talked about this. This is going to be the mid-segment of a triangle, okay? Another common mistake will be to, if you have another triangle, to try to draw in the median and then assume from that that my angles are congruent here. Right? But nothing tells me about the median that those angles are congruent. The only thing I can conclude is that that point over here is the midpoint, okay? And that tells me that the segments are congruent. It doesn't tell me anything about the angles. So in example 1, you can see the directions tell us to draw the median from each vertex. So by the end of this example, we will have 3 medians drawn in the picture. And as you can see at the bottom, I've kind of given you a reminder that the definition was the line segment from a vertex to the midpoint of the opposite side. So let's just pick a vertex to start at. Let's draw the median from vertex y. So if I know that I'm starting at vertex y, that means I have to go to the midpoint of the opposite side. So in all of these examples, your first step is really to identify what is the opposite side. And in this case, the opposite side of y is xz. And then I want to find the midpoint. Well, the midpoint of xz, I would say that's around here. I'm going to call this point A. But to actually show that I know that's the midpoint in the diagram, you have to use tick marks. So I'm going to say this segment XA is congruent to AZ because I know that midpoint split segments into 2 congruent parts, right? And then my last step is once I have my vertex and midpoint, I draw the line segment from the vertex connecting to the midpoint of the opposite side. Now let's look at the median from X. So following the same process, I have my vertex X. The opposite side in this case is YZ, okay? But again, I need to find the midpoint. So the midpoint of YZ is somewhere around here. Let's call that point B. And to show that I know that's the midpoint, I use tick marks. So in this case, I'm going to use 2 tick marks to tell us that it's a different side length. And then I'm going to draw my line segment from my vertex to the midpoint of the opposite side. And lastly, let's do vertex from the vertex Z. Okay, but following again the same process, I know that the side opposite of Z is XY. And I find the midpoint, which is around, I'd say, here. Okay, I show that in my diagram using these tick marks because I know midpoints split segments into 2 congruent parts. I'm going to call that point C, and then I connect my line from the vertex Z to midpoint C. And so now we've drawn 3 medians, median YA, median XB, and median ZC in the diagram. And interestingly enough, if you look at the diagram here, your medians, if you've drawn it accurately enough, they should have all intersected at one point. And this is kind of just a fun fact, but we call this point the centroid, and it's actually the balancing point of a triangle. So you could take, if you cut this out and you were exact, if that was exactly the centroid, you should be able to balance this triangle perfectly on your finger. So yeah, that's just a fun fact, but this point is called that centroid. The next vocab we're going to look at is we're going to talk about what is the altitude of a triangle. So the definition of an altitude is the line segment, again, from a vertex, but very importantly, it's perpendicular to the line containing the opposite side. And I'll tell you what that means when we go through this example. Let's look at a picture and the examples to help us understand this a little bit better. So if I have triangle HEF, okay, and we're going to draw an altitude from vertex E. From the last example of the medians, we should all be comfortable with recognizing that HF is the opposite side of E. But if you notice in our definition, we say that this altitude is perpendicular to the line containing the opposite side. And what I mean by that is what we can do is we can use dotted lines and we can actually extend the line segment HF to go on forever in both directions. And this is going to be really helpful when we do a specific type of altitude in the next example. Okay? But if I extend that, the blue dotted line, right, HF, is actually the line that contains this segment HF. Okay? And now, looking at our definition, we know that our altitude has to be perpendicular to this line. So that means that it has to go from vertex E, and it has to connect on a point on the line HF but specifically that point needs to be perpendicular. And we know that to signal that something is perpendicular, that it intersects at a right angle, and we put a little box there. Okay, so what we've just drawn is a line segment from vertex E that is perpendicular, okay, to that line HF that contains the opposite side. Again, I think it's really important to look at the characteristics so we can understand altitudes a little bit better. Similarly to the median, we can see, since there are 3 vertices of a triangle, that every triangle has 3 altitudes. And secondly, it might seem kind of obvious, but I think it's important to note that perpendicular lines intersect at right angles, which are 90 degrees. So let's look at some non-examples of altitudes and some common mistakes that will be made when drawing them. So if we look at example 1 here, if we have the triangle ABC and we want to draw the altitude from vertex A, right, it's perpendicular to the line containing the opposite side. So what will happen a lot is students will draw the perpendicular altitude, okay, but then also assume that this has split the opposite side into 2 congruent pieces. And now remember that this is a median. That's what a median does. That's not what an altitude does. So I can't assume here that these are congruent, that B, if we call this D, that BD is congruent to DC. I do not know that from the altitude. A second example that happens a lot is if we have triangle UXW, is to actually draw in a perpendicular segment, okay? But remember, if you look at the definition, it has to be from a vertex, okay? And in this case, this is not from a vertex. So again, this example does not work because your altitude does not start from a vertex. So looking at example 2, we're drawing altitudes, and in part A, we can see that we're drawing an altitude from vertex A. So if I'm starting at vertex A, again down here I've rewritten that definition. We know we have to start from the vertex and then be perpendicular to the line containing the opposite side. So my first step is to figure out, well, where's the line containing the opposite side? So the opposite side is CT, so this orange dotted line that I'm drawing, that's the line containing that side. And if I draw a perpendicular line from A to the orange dotted line, okay, and I note that this is perpendicular by using that right angle box, okay, I then have my my altitude, let's call this point B, my altitude AB, right? It starts at A and it goes perpendicular to that line containing the opposite side. Okay, what's important to notice here is that AB lies inside the triangle. Okay, and if we look at part B of this example, you'll see why I'm pointing that out. So looking at part B, I'm kind of confused because it says draw an altitude from M, but M is way over here, and I can't really figure out how I'm going to draw my altitude. And this is where that second part of the definition, to the line containing the opposite side, is super important. So again, let's think about the opposite side of M. Well, that's CI, okay? So like we've been doing, let's extend that line segment, okay, to this line. So my orange dotted line now is the line containing the opposite side. Now what I can see is if I look at the vertex M, I now can drop a perpendicular line segment to that orange dotted line. Okay, and again, I need that right triangle to help me identify that it's a perpendicular line. And so notice if I call this point, let's say N, then this new line segment I've drawn, MN, is my altitude, but it actually is outside of the triangle. Okay, and that's okay. because of the definition, right? It doesn't necessarily have to be inside the triangle. It just has to be perpendicular to the line containing the opposite side, which it is. So because of that, a really common mistake when I have this special case where I have to draw the altitude outside, if we look over here, a common mistake that I don't want to do is start at line M and try to draw that perpendicular segment inside of the triangle, right? If we look, I mean, you can kind of even tell, this is not perpendicular, okay? So this is an example where we have to extend those lines in order to be able to draw the altitude. Finally, we're just going to do one quick example with algebra. So if we look at example 3, it says, given that in triangle FHS, HG is the altitude and FO is the median. And then we have a bunch of given information here, but first let's figure out what does it mean in the picture to be an altitude and what does it mean to be a median. So if HG is the altitude, that means that they've intersected here at perpendicular, right? HG is perpendicular to FS. And since FO is the median, that means that O is the midpoint of the opposite side, and it has split the segment HS into two congruent pieces, HO and OS. Then let's take our givens and put them into the diagram. So I know that HO was y plus 2, angle HGS here, this was 2y minus 2x, and then OS was 5x plus 3. And again, one of our objectives was to be able to set up equations to solve. So my goal is to find x, y, and hs. And what I can see is I know that HO is congruent to OS because FO was the median. So I can set y plus 2 equal to 5x plus 3. Well, I'm looking at this and I'm thinking, okay, I have an equation with x's and y's. We should all be very comfortable with by now that this should be like a star in your head that says I'm going to need to solve using systems. Okay, and that means if I have two unknowns, I need another equation. Okay, so looking at my picture, my other equation here is, well, I have information about this angle. Okay, so I know that 2y minus 2x, I know that that has to equal 90 because it was perpendicular, and we know that that intersects at 90 degrees. Okay, so now I have two equations. What I would like you to do here is if you feel really confident about solving systems, I would like you to pause the video and actually solve this on your own and then check your final answer. If you feel like you need kind of guidance through another system, then you can keep the video playing and kind of follow along. Okay, so what I notice here is in this top blue equation, I actually think I can solve for y pretty easily here. So I'm going to do that first. I'm going to say that y equals 5x plus 1 if I subtract 2 from both sides. So to me, this seems like a good method to use substitution. Okay, so I'm going to take this y equals 5x plus 1 and plug it in for y in my other equation. So I get 2 times 5x plus 1 minus 2x equals 90, and I solve. So distributing first, we get 10x plus 2 minus 2x equals 90. Combining like terms, we get 8x plus 2 equals 90. And then solving the equation, we get 8x equals 88. Okay? Which, going over here, that makes x equal to 11. Okay? And then we take that x and we plug it back in to solve for y. So y equals 5 times 11 plus 1, or 56. So I've found x, I've found y, and my last step is now, how do I find HS? Well, HS is this entire segment here, and what I notice is I know that HO is congruent to OS. So to find HS, I can actually just plug it into that HO, y plus 2, so I do 56 plus 2, and then I can actually multiply it by 2, since HO is actually congruent. So I get 2 times 58, which gets me 116. Okay? And that's the end of the video. Okay, so hopefully you've unpaused it and checked your answer, and you got x equals 11, y equals 56, and HS is 116. We'll see you guys tomorrow.